Okay, so here I am. I'm logged into the AWS console. This is using the new UI, so it might look slightly different to some of the older accounts that are using the old UI. But if you need to get into the VPC section, you can just go down to networking or go up here to services and go over to networking and click on VPC. So this is our VPC dashboard. It tells us all the different instances, all the different things within our VPC. And up here, you'll see a Start VPC wizard. Now you can build out your own VPCs using this wizard. It's fantastic. It saves you a lot of time, but of course it means that you won't learn anything. You need to know how to do this for the exam. So we're not going to use the wizard. I'm going to show you how to build one out manually yourself. So I'm going to hit cancel and exit. And the first thing we need to do is go over to your VPCs and we're going to create a VPC. So the name, I'm just going to call it my VPC. And so then we have our CIDR block, and CIDR just stands for classless interdomain routing. And basically this is where we're going to specify what our IP address ranges are. Now, if you remember from the last lecture, there's 3 IP address ranges that are typically used, for internal network addresses. And 10.0.0 is the most common, certainly within corporate networks. So we're going to use that. And if you actually see up here, it will tell you that you cannot have a CIDR block that's larger than a /16 network. So 10.0.0.0 can go down to /8, but we're going to obviously, well, let's try it with a /8. It's going to throw up an error message if I go ahead and hit yes create. So there we go. I need to do it as a /16. That's the largest that you can have. And then we've got our tenancy down here. Basically, this is whether or not you're going to deploy your VPC and all the assets that sit within your VPC onto shared hardware or dedicated. By default, it's obviously always shared. That's the advantage of public cloud. But if you do have security things that you need to, regulatory requirements, and you need dedicated hardware underneath it, you can select dedicated. Don't do that though, because it can be quite expensive. So I'm going to leave that as default, and I'm going to go ahead and hit yes create. And it can sometimes take 1 or 2 seconds, but there we go. It's created our VPC. So here we go. We've got it, my VPC. We've got our VPC ID. We can see in here our VPC CIDR address range. So you can see our default VPC is our 172 address range. This is using the 10.0.0.0/16. We've got our DHCP option sets. We've got our route tables. We've got our network ACLs. We've got what the tenancy is and whether or not it's the default VPC or not. Okay, so let's go and have a look at what else was created when we created this VPC. If we go into subnets, we can see that there's 2 subnets, but these are for our default VPC, so it hasn't created any new subnets. If we go to route tables though, you'll see it has created a new route table for my VPC, and it's the main route table. So when you create a VPC, a main route table is created automatically. Let's go ahead and go over to our security groups and have a look over here. And again, you can see if we just move this across like this, and you can see it there, my VPC. So it did create a default security group for this VPC. Let's also have a look at our network ACLs, and of course, again, it has created a default network ACL for my VPC. So just to recap, when we created our our VPCs, it doesn't automatically create subnets. It also doesn't automatically create any kind of internet gateway, but it does automatically create a route table, a network ACL, and a security group. And that can be an important fact to remember when you go into any of the associate exams. Okay, so just to help you visualize what it is we've actually done, we've created our VPC. We've called it my VPC. I've done this in the European Central region just because I don't use this very much, and it allows me to demonstrate it to you without pre-existing security groups and that sort of thing. And then by default, when we created our VPC, it's created a route table, it's created network ACL, and it's created a default security group. We don't have any subnets available yet, and without subnets, we can't deploy anything into our VPC. So let's go ahead and create some subnets. So we click over here and go to subnets. We're going to create 2 subnets. And what I like to do in terms of the naming convention is I like to type in the address range, so 10.0.1.0, for example. And then I also like to put in the name what the availability zone it is in. So in this instance, we're going to use EU Central 1A. And I'm just going to change my VPC over to the VPC that we've created, so my VPC. And then the CIDR block, so I'm going to use 10.0.1 and I'm going to use a /24 address range and go ahead and hit yes create. And so straight away that will create my new subnet, and it's doing it in my custom VPC, and that subnet is always going to be in EU Central 1A. So again, this is so important to remember going into any of the exams. One subnet always equals one availability zone. You cannot have subnets spanning multiple availability zones. Okay, you can have security groups spanning multiple availability zones, you can have network ACLs spanning multiple availability zones, but one subnet always equals one availability zone. So we've created it. You can see over here, and this is quite cool as well. It tells you what how many available IP addresses are available. So we've got 251 addresses available in this in this subnet, and that's also can be certainly an exam topic in the professional level exams, is how many addresses does AWS reserve by default, and for each subnet that you create, 3 addresses are reserved by default, and I'm not counting the .0s and the .255s. And you can get that information very easily just by typing VPC IP reservations. It will bring up this web page, which is VPC and subnets. That's available at docs.aws.amazon.com/Amazon VPC/latest/user guide, and then /VPC_subnets.html. And then all we need to do is click on here, and you can see the 3 different IP address ranges that you can use, which are non-publicly routable. If you scroll down, you can see what's reserved. So 3 addresses are reserved automatically. That's .1, .2, and .3. Like I said, I'm not really counting .255 and .0 because you can't address them anyway. The .1 is reserved for AWS for the router. .2 is reserved by AWS for basically DNS services, and then .3 is reserved by AWS for future use. Now that probably won't come up in any of the associates exams, maybe in SysOps, but it is something important to remember for the professional exam. Okay, so coming back to the AWS Management Console, we're going to create our second subnet. Again, I'm just going to make sure it's in my custom VPC, and I'm going to call this 10.0.2.0, and then what availability zone that it's going to be in. So I'm going to specify that this one is going to be in EU Central 1B, so EU Central 1B. And so my CIDR address range is exactly what I've used in my name tag. So I'm going to use 10.0.2.0, and then I'm going to do a /24 and go ahead and create this subnet. So now we've got 2 subnets. One is in EU Central 1A, and the other one is in EU Central 1B. Each of them have 251 IP addresses available. And so basically I'm going to have one as a public subnet and one as a private subnet. So in order to make things public and private, the very first thing we need to do is attach a way of the internet being able to access this VPC. So how do we do that? Well, it would seem pretty obvious. We need to go over to Internet Gateways, and we're going to create an Internet Gateway. So let's call this my IGW, and go ahead and hit create. And then you can see by default it's detached. It's not doing anything. So we want to attach it to a VPC, and we're going to attach it to my VPC and go ahead and hit attach. Now, a common thing that will come up is whether or not you can boost your internet speeds by attaching multiple internet gateways to a VPC. Let's just create a new one. We'll call it my IGW2 and go ahead and hit yes create. So we've created that. If we go to attach to VPC, we're not going to have any VPCs in the drop-down menu, and that's because you cannot attach multiple internet gateways to a VPC. It just doesn't work like that. Remember that internet gateways are engineered to be highly resilient anyway. There's no single points of failure. You can't attach multiple internet gateways to a VPC to either boost its performance or to reduce any single points of failure. So I'm going to go ahead and just delete that one now. So we've got our internet gateway. It's attached to our VPC. Now, before we provision any EC2 instances into our subnets, we're going to have to create a route out to the internet so that those EC2 instances would be able to apply Yum updates, for example. They'll be able to patch their operating systems with the latest security patches. So we do that going into the route tables. Now, as you remember, when we created a VPC, it created a route table by default. This is it here. And you can actually, if you click here or maximize it a bit more, you can actually go in and see routes. So this route is always always created by default. So when we create multiple subnets inside this VPC, they will all be able to talk to each other. So this is the main route table. Basically, it's probably best practice to leave this as is and always make sure the main route table is private, just in terms of a security concern. And then what we want to do is we're going to create a new route table. We're going to call this my public route. And basically anything, subnets that are associated with this route table will have a route out to the internet, so it becomes very easy to track. So I'm going to go ahead and create this. We're going to select the My VPC and hit create. And that will create a brand new route table. And then what we want to do is we want to associate a subnet to this route table. Well, actually, first thing we want to do is create a route out to the internet. So let's do that. We'll go edit and we'll add another route. So right now we want to say that all traffic o.o.o.o/0. And then we go over to the target and it will automatically select your internet gateway. So you just point it to your internet gateway and you go ahead and hit save. Okay, so there we go. So what have we actually done? Well, we've created a new route table and we've given that route table a route out to the internet, and it's not our main route table. And one thing to note is that whenever you create a new subnet, by default, it will always be associated with your main route table. And for that exact reason, you probably don't want a route out to the internet on your main route table, because it means that every single subnet that you create by default will be internet accessible. And it's not very good in terms of security best practices. So there we go. We've created our new route. We've given it a route out to the internet. The last thing we need to do now is associate a subnet to it. So we'll click on subnet associations. It says here you do not have any subnet associations, and then it always gives you this warning: the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So what we want to do is we're going to go edit and we're going to associate our 1.0, so our EU Central 1A, and that's going to basically make this subnet associated with this route table, and it will give us internet access to anyone or any EC2 instances that are deployed into this subnet. So I'm going to go ahead and hit save, and there we go. It's creating our route table. Now there's one last thing that we probably want to do before we deploy an EC2 instance into it, and that's just go over to our subnets. And you can see here we've got our 1.0 and our 2.0. If we click on the 1.0 and if we go all the way across, you can see here it says auto assign public IP addresses, and right now it says no. Now of course this subnet is supposed to be our public subnet. We do want any EC2 instance going into this subnet to be available to the internet. So I'm just going to go to subnet actions and I'm going to go modify auto assign public IP, and I'm going to go ahead and hit enable auto assign public IP and save that there. So now every time I deploy an EC2 instance into this subnet, it's going to basically automatically assign a public IP address to it. So let's go ahead and deploy two EC2 instances, one into 1.0 and one into 2.0. So I'm going to go ahead over here. I'm going to go and click on EC2, which is under compute services, and then I'm going to go in and start launching some instances. So I'm going to use the Amazon Linux AMI. I'm going to go ahead and hit next. I'm going to make sure I'm using my new VPC, not the default VPC. You can see the number of IP addresses available, and then I want it to obviously go into my 1.0 because that's going to be my public subnet. And I'm going to leave everything else as is, but I'm going to go down here and just write a cool little bootstrap script. Before I do that though, do take notice of this. Auto assign public IP addresses, use the subnet setting. If you forgot to enable it in the subnet section, you can also just hit enable here and it will always give it a public IP address as well. But right now, because we did enable it in the subnet setting section, we can just use subnet settings. So we'll go down here and I'm going to write a cool little bootstrap script. Okay, so as always, we start with our shebang, which is just the number sign followed by an exclamation mark and then the path to our interpreter, and our interpreter basically just interprets our bash commands. So it's /bin/bash. The first thing we're going to do is we're going to do yum install httpd -yes, Then we're going to apply our update, so yum update minus yes. Then we're going to turn on the Apache service, so we're going to make this into a little web server, so service HTTPD start. We're also going to make it so that if this EC2 instance reboots, it will automatically start the HTTPD service. We do check config HTTPD on. And then the very last thing we're going to do is create our own little web page. So we're going to do echo, open quotation marks, and I'm just going to do a little bit of HTML here. So HTML header 1, and it will just say, hello, cloud gurus, with an exclamation mark at the end. Close out our header, close out our HTML tag, and then close out our exclamation marks. And then we're going to write this to our var www HTML directory, and we're going to call it index.html. And that's literally it. Very simple little bootstrap script. I'm going to copy and paste this, and we'll have it in the resource sections of the course. Go ahead and hit next to add our storage. We'll keep the storage as default, and I'm just going to call this my web server as its name. Go ahead and configure our security group. Now, because this is a new VPC, we're going to create a new security group. I'm going to call it web DMZ, web DMZ, and I'm going to open this up to port 80 as well as SSH. So we're going to allow HTTP traffic into anything in the security group. I'm going to go ahead and hit review and launch. So we're all good to go, and we're going to go ahead and hit launch. I have an existing key pair called my German key pair. You might want to create a new one if you don't have a key pair in this region. Go ahead and hit launch instances. So there we go. If we go back to viewing our instances, here's a naughty one I had to terminate earlier because I did a mistake in the bootstrap script. But this one is being provisioned right now. And what you will notice is that if you've done it right in terms of your subnets and enabling auto allocation of IP addresses, this new EC2 instance, once it has been provisioned, will automatically have a public IP address. Now, if yours doesn't, it just means that you didn't add that to your subnet when you first created it. There's an easy way around it, is you can just go and provision a basically a elastic IP address, and you do that just by going down over here, clicking on elastic IPs. Let's go ahead and just have a quick look at how we do it. So you'd allocate a new address, yes, allocate, and then you would basically assign this elastic IP address associated to your EC2 instance. I'm going to go and just release this address though. So go ahead and hit yes, release. So let's go back to our EC2 dashboard and have a look at our instance. It should hopefully have come up. There it is, and we've got our public IP address already assigned. And it depends on how long the bootstrap script takes to run, but let's go ahead and just, so let's paste in the IP address in here, hit enter, and with any luck, there we go, hello Cloud Gurus. So it has all worked, and it is internet accessible. We can access it via HTTP. We should also be able to SSH into that instance using the public IP address.